Narrated solution number 1, it says revolve the region bounded by y equals 6 minus 2x minus x squared and y equals x plus 6 about the x-axis. So the first thing we want to do when we do these types of problems is to always draw a sketch. And the only way to get an accurate sketch is to first find the points of intersection and then get a few points on the graph and then draw what that function is going to look like graphed in the coordinate plane. So go ahead and pause the video, copy down all these pictures, and then we'll hit it. Hello, welcome back. Okay, so if you'll notice, when we drew this picture, right, the big difference between the disk method to generate the volume of a solid and the washer method to generate the volume of a solid is that there is going to be a space between the function and the axis of revolution. And that space is what's going to create an inner radius because there's going to be space between the axis of revolution and the function. And you will have an inner radius of the washer and an outer radius of the washer. So first, let's generate the volume of this washer, or our increment of volume. And the way we're going to do that is by setting up our delta VI, or our increment of volume. And we're going to still have that pi out front because we're still technically generating the volume of a cylinder, but we have to account for the fact that there is now a space in the middle. So we need to subtract the volume of that space in the middle. So we have the outer radius, which will be generated by the function 6 minus 2x minus xi squared. That whole thing is squared because that's kind of the volume of the outer cylinder, minus the volume of the inner cylinder, which is going to be generated by the function xi plus 6. We're going to square that. And then this pi is multiplied by everything. And then we have a dx at the end. Let's see if we can kind of clean this up a little bit. So if we have our increment of volume, or the volume of the washer, it would be pi times xi to the 4th plus, right, I'm just expanding this guy here with his squared, I'm expanding this guy here with his squared, plus 4xi cubed minus 9xi squared minus 36xi. And that'll all be multiplied by, sorry, that does not look like a triangle, dx, or delta x. Okay, so now we have our increment of volume. Let's go ahead and add up all of those washers. We're going to generate our Raymond sum. We're going to start with one disk, and we're going to add up until we get to n disks. So we have xi to the 4th plus 4xi cubed minus 9xi squared minus 36xi, and we have a little delta x at the end. Okay? So then now we are going to let the number of washers approach infinity, and we're going to generate our integral. Oh, let's put that pi out front. I don't like dealing with him till the end. And we're going to integrate from -3 to 0. How did we determine those bounds? Well, the graph is going from -3 to 0 visually along the x-axis. And then we have our function here, x to the 4th plus 4x cubed minus 9x squared minus 36 dx. And it's so nice that this was kind of split up as a polynomial, because then we can just integrate each piece. And if you pause the video and you want to work this out on your own, on your calculator or on paper, you should get 243 pi over 5 units cubed. If you hear a weird noise, that's because we are doing work in the basement simultaneously. Thank you.